All right, so we've got a couple of sections on circles, and we just ended our circle chapter, but we're not really talking about any of those properties that we were looking at in that section. We are looking at finding, in this section, circumference, excuse me, and arc length, and then in the other one we look at the area of a circle and then area just of a chunk of the circle. So just a little bit of review here though. Diameter is simply the distance all the way across the circle going through the center. Circumference is the distance around the circle. Okay, so it's actually the length of this curve that goes all the way around. And if you don't have a pi button on your calculator, which all of you should, when you're punching in these problems, you need to go all the way out to 9. And if they say leave it in terms of pi, you simply just leave pi on the answer and you don't have to multiply that part out. Okay, so there's two formulas for circumference. Does anyone remember them? That's area, so save that one for tomorrow. Yep. 2 pi r is one of them. Does anyone remember the other? What is 2 times r? The diameter. So another way to write it is pi d. Okay, so those are interchangeable. They're really the same thing, but you can use either one. So if you have a problem like this, whatever object they give you, that's probably the formula that would be easiest to use. So what is this called right here? Yeah, that's the radius. So we're going to use the one that has the radius. Now we always do 3 lines of work. So we write the formula. We put the numbers in that we know. And then we write the answer. Okay, formula, numbers in, answer. Every single time.
You just,
Because 2 times 5 is 10, and 10 times pi, you just move the decimal over once. So it's really just 3.14, but you move the decimal. Yep, you multiply them all together.
Could you just use the other one and multiply 5 by 2?
You could. Yep. Questions there? Now, when they say approximate circumference, that means that you are rounding a decimal. Okay, so this right here is the approximate circumference. It's not exactly the circumference because we had to cut off all those numbers on the end. Okay, so this is the approximate. If we want the exact circumference on this one, we have the diameter, so we go C equals pi d. C equals pi 12. This one I'm going to need help with. Can't do it in my head. Okay, now, they wanted the exact circumference. So if we were doing approximate, you told me that it's 37.6. But if they want the exact, here's how you write it. 12 pi meters. Okay, so you don't actually multiply by pi. You leave pi as part of the answer. That's the exact circumference because we didn't have to round it off. Questions there? All right. So a couple of these. Find the radius when the circumference is 18 pi. So these we work backwards. So we're looking for the radius. So we're going to start with the formula that has the radius in it. Okay, what do we know on this one? Yep, 18 pi equals 2 pi r. What can we do to both sides to solve for r? Okay, we could divide by pi. That cancels out the pi's. So now we just have 18 equals 2r. And divide by 2. Okay, so 9 is our answer. Okay, find the diameter. So now we use C equals pi d when their circumference is 28. Now, sometimes it's going to be a number with pi on it, and sometimes it isn't. So make sure you use whatever they give you. So we've got 28 equals pi d. How do we solve for d? Divide by pi. So this one's going to be a decimal. Somebody help me out. Questions? Okay. All right. Before we go on to talk about arc length, what would this x value be? 360 minus 225. It would be 135 because all we're doing is taking the whole circle minus whatever degrees are here. Okay, so that's just a reminder before we jump into arc length. All right, so circumference finds all the way around the circle. Arc length just finds part of that circumference, so just an arc. Okay, so to talk about that, we need to have a reminder of these. We talked about these before. So arc is just part of a circle, semicircle is half a circle, minor arc is less than half, major arc is more than half. So looking on this picture right here, which arc is a minor arc? BC or CB? Okay, the symbol above it is an arc. And what would we name the major arc? What? It's either BAC or CAB, but either one would work. Okay, and that goes all the way around the larger part of the circle.
So you have to do it in that order?
Or it could be CAB. You just have to go in a, you have to follow in order, but you can start over here and go around the other way. All right, so let's try this arc length stuff. Arc length is just a fraction of the circumference. Now, this is a reminder from last chapter. The measure of an arc is the same as the measure of the central angle. So remember when we had a circle, and if this angle right here was 80, the measure of the arc was also 80, right? Okay, so our formula right here is going to require the measure of the arc, or just the measure of the central angle. Okay, I'll show you what it looks like in practice here. So if we have this picture right here and we want to find arc length, here's our formula. AL is arc length is equal to MAB over 360 and then 2 pi r on the end. So there's only two things we need to put in. We need to have the measure of the arc and the radius. And then we throw it all in the calculator at one time. Okay, so if we're looking for this arc right here, AL equals, what's going to go up here? It is a 90-degree angle at the center over 360, 2 pi 14. Okay, this is the diameter right here, 28, so we got to cut that in half. So I want everybody to put this in their calculator and make sure we can all get the same decimal answer. When you have one of the TI-30Xs that most of you have, you don't need any multiplication symbols in this whole thing. Okay, you put a parenthesis, 90, you can either do the fraction bar or the divide, 360, parenthesis, and then just put 2 pi 14, it'll multiply it all together for you. What do we get?
21.991.
Anyone not able to get that? We're good?
What do you want us to round?
This one could have been rounded to 22.0, and that would have been fine. One or two numbers after is good. All right, so this one we're looking for XZ. So we've got arc length equals measure of AB, 360, 2 pi r. Everybody write this down. Okay, the way I do these problems in this chapter and the next chapter, I always write down the formula and then I kind of write in the skeleton of the formula so that I can just drop the numbers in that need to go in. So what is the angle going to be for XZ? It is going to be 110. We have to take 360 minus this 250 to get that angle right there. Okay, what's our radius? 6. Throw it in the calculator. What do we get?
11.519. You want to write the formula so we remember it?
The formula we write because in the next chapter we're going to have multiple formulas that we all add together and it just keeps it organized and there's less mistakes in the long run. So it's just a good habit to get into. And if the only mistake you make is that you write the wrong formula, because tomorrow we're going to learn a formula that looks just like this, but a little bit different. If that's the only mistake you make, but you do all the work right, then I know I can give you partial credit, basically. Questions? All right, we've got two working backwards problems we're going to go through. So this one we're looking for the measure of AB. So we want to know how big is that angle right there. Okay, so let's start with the formula. We've got arc length equals measure of AB over 360 2 pi r. So what are the things that we know? Yes. Mm-hmm. The angle is what we're looking for, so we put an x there. And then we've got 2 pi, and it looks like the radius is 12. Okay, here's the easiest way to solve these. We want to get x by itself, obviously. So let's just figure out what that number would be right there, and everything else will stay the same. So 25 equals x over 360 times what number?
75.
Since we're halfway through a problem, let's put a little more decimals on there, or numbers after.
398.
398, perfect. We'll cut it off at the end, but halfway through a problem, it's good to have more numbers. Okay, how could we get x by itself a little more? Multiply by? No. We could multiply both sides by something, or we could divide both sides by something. Either one would be fine. We can divide by 75. Let's do that first. Okay, so we're left with 0. What? 33. And the only thing over here is x over 360. How do you get rid of that 360 over there so x is by itself? This is where we multiply, yes. Okay, so we multiply by that 360, and we get 120 equals x. Questions there? We got one left. It's really just writing the formula, putting the numbers in where you need them, and then get x by itself. Okay, find the circumference to the nearest tenth. So in order to find the circumference, what do we need? What's the formula for that? 2 pi r, right? We need the radius. Do we have the radius?
No.
No. Okay, but we can find it. So we need to find the radius here. So we're going to start with arc length equals measure of AB over 360, 2 pi r. All right, so on this one, we do have the arc length and we have the angle. So we can put those two things in. We have 7 and we have 50. And then we have 2 pi x. Now, when you're missing the radius, the easiest thing to do is to figure out what this number is. Because then we can just keep the x on the end of it. Someone punch that in for me. How much? 0.872x. How do we get x by itself? Divide by that decimal. What do we get? 8.0. So basically 8. Okay, so we just found the radius. Can we now solve this problem at the bottom? Very easily, right? Okay, so we've got c equals 2 pi 8. C equals 50 point how much? 3 centimeters. Questions there?